Example 4. Ages. Jennifer is twice as old as Ramon. The sum of their ages 7 years ago was 13. How old are they now? So let's let J be Jennifer, R be Ramon. Our first sentence, Jennifer is twice as old as Ramon. Jennifer is twice as old as Ramon. The sum of their ages 7 years ago was 13. Sum means we're adding. We're adding their ages 7 years ago. Now J and R stand for their ages now, but we want their ages 7 years ago. So we're going to take Jennifer and subtract 7. We're going to take Ramon and subtract 7. The sum of their ages 7 years ago was 13. So that's our two equations, and we have two variables. I think we need to straighten this second equation up a bit. We could get J plus R. We have minus 14, so if we added 14 to both sides, that would equal 27. So now I like those two equations. J equals 2R, and J plus R equals 27. So the question is, how are we going to solve this system of equations? What do you think? Substitution or elimination? I like substitution because we already know what J is. J is 2 plus R. So we're going to rewrite the second equation. We're going to take that information and put it into the second equation. So instead of J, we're going to write 2R plus R equals 27. 3R equals 27. What is R? Divide both sides by 3. R is 9. If R is 9, what is J? Well, we know that J is 2R, so it's 2 times 9. So J is 18. So writing our answer in a sentence, Jennifer is 18 and Ramon is 9. That's our solution. Jennifer is 18 and Ramon is 9. Next question. Supplementary angles. Do you remember what supplementary angles are? There are two angles that if you add them, you will get 180 degrees. Two supplementary angles are such that one, let's call that 1x. 1 is 30 degrees less than, we're going to have to subtract 30. 30 degrees less than twice the other. So let's call the other one y. 1 is 30 degrees less than twice the other. So that is our first equation. X equals 2y minus 30. What about the other equation? Well, we know these two angles. We're calling one x, we're calling one y. The other equation is x plus y equals 180. So that gives us two equations. This system of equations, once again, seems to me to be a very easy system to solve using substitution. We know x equals 2y minus 30, so why not put that, substitute that into the first equation in place of x. So we have 2y minus 30 plus y equals 180. So that gives us 3y minus 30 equals 180. Add 30 to both sides, 3y equals 210. Divide both sides by 3, and we get y equals 70. So one angle is 70. What is the other angle? There are many different ways we can solve for the other angle. One way is to look at x equals 2y minus 30. That's what we substituted into the second equation. And we let x equals, since we know now that y is 70, it's 2 times 70 minus 30. So x is 140 minus 30. X is 110. And notice that they add up to 180 degrees. That makes sense because they are supplementary. The angles are 70 degrees and 110 degrees. Sometimes it's nice to go ahead and reread the problem. Two supplementary angles are such that one is 30 degrees less than twice the other. So one is 70, and twice 70 is 140, and 30 degrees less than that is 110. So those angle measurements make sense. Jed's student loans totaled $16,200. Part was a Perkins loan paid at 5% interest, and the rest was a Stafford loan made at 4% interest. After 1 year, Jed's loans accumulated $715 in interest. What was the amount of each loan? So, he's got two different loans. One is a Perkins loan. The Perkins loan is made at 5% interest. The other is a Stafford loan, and it's 4% interest. He borrowed a total of $16,200. So if we add the Perkins loan plus the Stafford loan, we should get that $16,200. Let's talk about the interest. If you take 5%, 5 over 100, 5% of the Perkins loan plus 4% of the Stafford loan, that's the interest from the Perkins loan plus the interest from the Stafford loan. Altogether, you'll get $715 in interest. So we have P plus S equals 16,200. And we have 0.05 P plus 0.04 S equals 715. Two equations, two variables. That's what we're going to solve. Substitution or elimination. You can solve it either way. I'm going to use elimination. If you want to use substitution, stop the video, solve it with substitution, and see if we agree. I'm going to eliminate the P, so I'm going to multiply the first equation by negative 0.05, the opposite of positive 0.05, and that will give me negative 0.05 P minus 0.05 S equals negative $810. So, we now have two equations in P and S. P has 0.05 in one equation, negative 0.05 coefficient in the other. So they will be eliminated when you add them together. You get negative 0.01 S equals 715 minus 810, which is negative 95. And if you divide both sides by negative 0.01, you get 95 divided by 0.01. The negatives cancel. So you get S is $9,500. How much is P? Well, we know that P plus S equals 16,200. So if S is 9,500, we can subtract 9,500 from both sides, and we will get that P is $6,700. Putting our answer in a complete sentence, his Perkins loan is $6,700, and his Stafford loan is $9,500. And that's our answer. Example 7, a landscape architect designs a garden with a perimeter of 44 feet. The width is 2 feet less than the length. Find the length and width. So this is a rectangular garden. The perimeter is 44 feet. The width is 2 feet less than the length. So our equations are, the width is 2 feet less than the length, that's one of them, and the other is that the perimeter is 44 feet. We know that the perimeter equation is twice the length plus twice the width, and now we know that perimeter is 44 feet. So those are our two equations. This system is pretty much begging to be solved by substitution because width is length minus 2. So we're going to rewrite that 44 equals 2L plus 2W, but instead of W, we're going to put L minus 2. So now we have 44 equals 2L plus 2L minus 4. Add 4 to both sides, 48 equals 4L. Divide both sides by 4, and you get L is 12. The length is 12. What is the width? Well, the width is the length minus 2. So it's 12 minus 2. So it's 10. And our unit of measurement is feet. The garden is 10 feet by 12 feet. And the perimeter is 44 feet. Mula has 27 coins that are all dimes and quarters. The value of the coins is $4.35. How many dimes and how many quarters does Mula have? 27 coins altogether, and they're dimes and quarters. Dimes plus quarters equals 27. How much money is it worth? Well, you need to take 10 cents for every dime, 25 cents for every quarter, and that'll tell you how much money it's worth, $4.35. So we have one equation for the number of coins and one equation for the value of the coins. So let's solve this system. I'm going to solve it by elimination. I want to eliminate the d's, so I'm going to multiply this first equation by the opposite of 0.10, so negative 0.10. That will give me negative 0.10d minus 0.10q equals negative 2.7. The d's are eliminated. I get 0.15q equals 1.65. Divide both sides by 0.15. And we get 1.65 divided by 0.15. 11. There are 11 quarters. If there are 11 quarters and there are 27 coins altogether, how many are dimes? 16. There are 11 quarters and 16 dimes. And that's the answer. That's all for Part B of 4.4 application problems.